One of the more complicated calcs that is prevalent in the retail and consumer product industry is to figure out the variance between actuals and budgets that is due to price, volume, or mix. This helps in determining how to manage your business. In this example spreadsheet, we want to determine the variance here of 8,500. How much of that variance is due to price, due to volume, and due to mix? And we want to see the price as it looks between actual and budget, the volume between actual and budget, and then the mix is actually the total mix of product 1, 2, 3, and 4 against all the total products. As you can see, the calcs refer to different cells in the view. These are complex calcs that traverse over different scenarios and different products. It is somewhat difficult in this paradigm to understand what is actually going on, and some of the cells are hard-coded so that it works. So it gets to the situation here where how do you actually manage this as well as maintain these algorithms across many, many different products as opposed to just a sample of 4. So to take this spreadsheet and develop it into a Rumfox pivot table, what we've done is we set up the accounts as such. So you can see them right here. We then can move over to the different scenarios, and you can see those in the spreadsheet as well. You can see the different products. We actually extended upon the products so you can actually see the results as well as if you had more products. So here are the 3 dimensions that make up the pivot table. So let's take a look at the Rumfox rules. This is one of the real powers of the solution. As you can see, the calcs are written in a business language that users can understand. This becomes incredibly important when handling complex algorithms when you are cross-referencing different dimensions. For instance, variance due to price as a units of actual times the variance in price. This relativeness is extremely important also when creating the rules because the logic is system generated and properly propagated across the database without the potential of user error. For the variance due to mix, this is also an example of the power of the dynamic rule logic because it is building the model with rules that reference totals, and as the products may change, the rules will move accordingly. And as you can see here in the rule, it's referencing the total product group, and you can see how that formula is produced. So let's go ahead and save these and run these calcs and move on to the next step. So let's jump over to our views and open up one of the views that we have set up to review the calculations. And what I did is I set up exactly like the layout on the Excel spreadsheet. This way I can just copy it, paste it right underneath just as formula so I can see as values and see how they interrelate. And as you can see here, everything checks out. As far as product 1, we're set, same variances. Product 2, same variances. Product 3, product 4 is the same, and now for the total groups themselves, we have everything checking the way we wanted. Finally, let's open up another view here. Set up a report to kind of show those variances just in a simpler view. Now that we have them inside our pivot table, we can actually see the variances across all the different product groups. And in fact, if we want, we can now leverage Excel to graphically represent these variances. So now as I open this up, you can graphically display what's going on inside the Rumfox pivot table. Maybe what we're going to do here is keep the properties of the chart constant. That way when we open it up to see the details, we can see the details on the variances due to price, volume, and mix.